Okay, boys and girls, today we are going to correct our homework from the other day, and I'm just going to run through the other practice problems because my class didn't have a chance to do a live lesson. So here we had to draw an identical copy of each triangle to make a parallelogram. We can create a parallelogram from any triangle using the same base and height. So here we see, here's the base. Here's the base. And the height. So if we just repeat that, the base and the height, then we can get a parallelogram out of each triangle that we see here. Base, height. So the reason we start with this today is because we're going to build off that idea to both locate the base and the height and also understand how to find the area of a triangle. So here we can study the examples of examples and non-examples of bases and heights in a triangle and answer the following questions. These dashed line segments represent the height of a triangle. So I'm just going to highlight the height that I see here. Height, 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 height. And if you look at this triangle, it's exactly the same triangle, okay? So all three of these represent where they're correctly labeled the height. These dashed lines do not represent the height. So these are not correct, okay? So we're gonna go back up and look at our picture each time we read a statement. We're gonna select all that are true about the base and the heights in a triangle. Any side of the triangle can be the base. Okay, I look here. Here the base is at the bottom. Here it's on the side. Here it's on the top. So that looks to be true. Okay, there is only one possible height. Well, I can see that's not true because here there's three different heights listed, a height here and a height here. A height is always one of the sides of the triangle. If I look along the top, it's actually there's not a single side that fits that. And if I look down here, here's one where the height is labeled here and that says it does not represent it. So that's a no. The height that corresponds to a base must be drawn at an acute angle. Okay, so let's make sense of that. So it's saying here's the base, and that the angle that is formed by the height and the base is acute. Well, we know that sign to be 90, so that is not true. But 5 is true because it says a right angle, and a right angle means 90. Okay, so that's true. Right angle means equals 90 degrees, okay? Once we choose a base, there's only one segment that represents a corresponding height. So once we choose a base, there's only one. Well, that might be true if we were only looking at these two pictures, but we can see that's not true. That this right here, even though it goes off the shape, it spans the whole distance to the top. So that could also be considered the height. Okay, and like if I were to follow that same logic, this could come out here like that and be the height. Notice that these heights are parallel to each other. These heights are parallel to each other. So not true. The segment representing the height must go through the vertex. Here's the vertex, vertex, vertex. Here it goes through, but it doesn't, and it does here, but it doesn't over here. And it doesn't in these two, so no. Okay, so now, last one. We're going to use what we learned from those other two to help us here. So we have to find we have to label the base and a segment showing its corresponding height. Okay, so here I can see it's kind of hard to see in this, but there's a dotted line here. So this has to be my base, and that's my height. And here, this is the base. This one's a little harder, and it was really hard to see this height out here. So that might have thrown you a little off. And then I'm just going to count it because I don't have numbers, but I do remember area is the number of squares that cover a surface. So I want to know the number of squares that the triangle covers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was my base is 10. And then my height is 1, 2, 3, 4, 5, 6, 7, 7. Okay. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the height is 1, 2, 3. Okay, Now, let's just break down what that means. Remember, if we take and we multiply 10 times 7, what we're really finding is the area of a rectangle or the area of a parallelogram, depending on the triangle. So if that's the case, then if we compare this, if this was 10 by 7, which the whole area would be 70, okay? If we wrote 70 here for our area of the triangle below, that wouldn't be correct because we only have one of them. So I am going to say 10 times 7, and I'm going to get 70, but then I'm going to take and I have to cut that in half to get 35 units squared. Okay, and I'm going to do something similar here. If we were to draw this triangle, remember we can take and we can make a parallelogram. Oop, that wasn't a very good drawing. A parallelogram using the same base. So here's the base. Let's see how I do. Pretty close. Okay, again, these, if we were to put the dimensions in, this is 10 by 3, which is true for up top there, our diagram. But again, we're only looking at finding the area of one of these. So 10 times 3 equals 30, but we want 1/2 of this parallelogram, so we get 15 square units, or units squared. Okay, thanks for listening.